the first approach that most people try to scale this is to take their program that runs on a single machine and try to make it run on a host of machines. So it turns out that this kind of architecture where you're taking a simple node and replicating it turns out to be a very, very hard problem. There are lots of challenges in getting the data spread across the machines, making it consistent, building distributed algorithms, and making sure your logic is able to use all of these things effectively. We end up with our current system architecture, where you basically use an analytics engine. So an analytics engine is able to not only handle the data scale, but also is able to operate on this with distributed algorithms. And then you're just left interacting with this engine using a high-level language like SQL. For the batch use cases, we take in the same data, but then we ingest it into a data lake. And then we run some analytics on top of it, some transforms. We create data models, and then we provide another query interface on top of these data models for users to build reports, do analysis, and power machine learning. On the batch side, we run our ingestion jobs on Spark. We have built our data lake using open source technologies, Apache Hudi, which is something we built at Uber and contributed. We use Parquet as a file format and Hadoop as a storage layer. And then we have Hive jobs, which we then take to ingest data from the data lake and build our data model using pretty much the same stack. So we have Hudi as a table format, Parquet for files, and Hadoop to serve all the data. And finally, the engine that powers interactive queries on top of our data lake and data model is Presto. As you can see, this is what SQL provides, right? If you have a declarative language, then you can decouple it from your implementation. And under the hood, you can convert it using a variety of engines to serve pretty much every single use case you have for your data infrastructure in your company. So first, for our data, we build reliability and scalability by storing multiple copies, right? So we have multiple copies. So in case one copy is corrupted, we have two more. And if there are hot shards, we can add more replicas so that we can handle the read traffic. We also use erasure coding and tiered storage for older data so that we have a much more efficient way to do this at scale. And for our table format, Hudi, from Uber, we have contributed record index, which is an advanced way to build a transactional layer on top of Hudi, which does not use a side key value store like HBase. So this format allows us to build a transactional layer extremely scalably on top of HDFS. One of the first optimizations we did in the stack is our Hudi listing optimization. So we are able to be smart about the way we do listing on Hudi, and we've optimized Presto to do this. We've also integrated Alluxio library within Presto workers so that we can use the local SSD to cache data. So these are high access data, so sort of DIM tables that are used commonly, high value fact tables in some cases, the most recent partitions. And we use affinity scheduling to make sure that the cache is properly exploited. Similarly, on storage side, we use Alluxio local SSDs to cache for faster I/O. As you can see, with a single SSD, we are able to replicate and keep a copy of all the hot data so that all the reads run very fast. For our data cloud, we are currently building it out on Google Cloud. Here, again, we're using HiveSync to copy data from HDFS to Google Cloud Object Storage. But interestingly, we are directly using the object storage without HDFS in the middle. And we've actually been pretty impressed with the performance we're getting here.